Hello YouTube. Today I'll be doing a video on teaching you guys how to do basic transformation on a cosine graph. Okay, so let's start off with the equation for that has transformation for a cosine graph. So let's say we have f of x equals 2 cos and 2 bracket x negative 90 bracket close plus 1. Okay, so first let's identify our transformations here compared to our basic graph, which is just cos x, right? So what's different about from cos x to this new equation that we have? So let me just do something in a different color. Right, okay. So first of all we have this number 2, and this 2 is our amplitude. And amplitude, I discussed in the last video, is just how much it oscillates from its mean value, how much it goes up and down from its mean value. And we have another 2, which is after the cosine, and that's our horizontal stretch. And horizontal stretch determines how much it compresses or decompresses. And this also deals with period, figuring out how long will a cycle take. And for equation for that is 2 pi stretch spelled wrong, stretch right, horizontal stretch. So our equation for a period is basically 360 over the horizontal stretch, right, which let's just say it's k, equals your period, right? And as we discussed in the last video, the period represents how long it takes for one cycle to start and finish, right? So this is a very key equation to memorize, right? And now what's this negative 90, right? Negative 90 is our horizontal shift, as you can call it our horizontal shift. And our horizontal shift tells us where will the graph start, where will the originating point will be. Since it's negative, it's always the opposite, right? So if it's positive, right, let's draw a graph here. If it's positive in the bracket, then it will start from the left of 90 degrees, right? If this was positive, but it's negative, so we know it's going to start from the positive 90 degrees. It's counterintuitive, right? So it's going to always start from its opposite value, right? And our 1 at the end is our vertical shift or our vertical displacement. Or our mean value, right? Mean value. And this is basically this is basically the value of the middle of your graph, right? So in our normal sine graph or cosine graph in this case, right, it was 0 because the middle of the graph, right, well, here's the cosine graph starting from here, so the middle of the graph was 0, right? But in this case it's 1. So your mean value and your horizontal displacement, right, horizontal D displacement determines where your beginning value or where you're going to start to graph off, right? So since we know all our amplitude, all our variables to drawing the graph, so let's now draw a graph. And as you can see how much it differs from a normal cosine graph, which is just cos of x. Okay. So now let's use a different color to draw these. Okay. So let's first figure our period, how long it takes for one cycle to complete itself. That's basically 360, right, over 2, which gives us, well, 180, right? It takes 180 degrees, or half of, well, 1 pi to complete one full cycle. And a cycle, I have discussed this in my previous video. What is a cycle? So, you know it takes 180 degrees to one cycle to be completed. But we also have our shifts here. We have our 90 degrees to the right, because it's negative, so it goes to the positive side ahead, 9 degrees, and 1 up. So this is our 1. Let's say this is our 1, and say this is our 60. This is 60. Right, this is our 120. Whoa. And then this is our 180. 240. 300. 360. Right, or 2 pi. Right. So this is 2 pi, 1 pi, half a pi, which is, well, 90, right? And 1/2 of a pi, which is 270. Now, we know that our graph here starts at 90 degrees from here on the right side of the graph, which is the positive side. So you're going to put a dot there, right? So it starts from here. And we know our mean value is 1. So once you know our mean value, we can just put our new x-axis here. This is our basically new x-axis, that's 1, right? So this is our, well, the first value is 1. And we know we're doing a cosine graph, right? And we know that our maximum value is just going to be, well, the vertical displacement, right, VD, plus the amplitude, which is A, right, which our max value, right? And our min value is just V dot D take away from our amplitude. So what's our amplitude? So what's our VD, which is here 1, plus 2 equals 3. So our maximum value is gonna be 3, positive 3, right? And now what's our minimum value gonna be? Well, same thing again. Vertical displacement take away 2. Well, you know it's gonna be a negative number, right? Because 1 is bigger than 2, so it's basically looks like 1 take away 2, right? This should give you a -1, and -1 is our lowest value in this case. So first we've gotten this sorted out. What's our minimum, maximum? And now I will draw little dot lines, right? And these lines really help because they really tell you that what your constraints or what your restrictions are, right? So if you go past these lines, say if you go to 4 or go to -2, you know you're doing something wrong, because these are your maximum minimum value, and the graph should not pass between these 2 points, which is -1 and +3, and 1 is your middle line, and that's your mean value right here, right? So yeah, so now let's start the graph. So let's do our shifts first, which is our horizontal and vertical displacement, or horizontal displacement, which is 90 degrees to the right and 1 up. So 90 degrees to the right and 1 up. Let's use a different color because it's blending in. Here we go. So let's do our 90 degrees to the right, 1 up, right? And then, but this is a cosine graph, right? So this is, we're assuming, well, normally it was a 0, right?